Fasteners for assembly drawing. There is a substantial amount of knowledge that is needed before you can assemble a drawing. Now, let's go back to our grade 11 work, which is what we're looking at the moment. Now, remember, all of this, what we are doing, assembly drawing, is supposed to be in that angle, orthographic projection. So we need to be familiar with all of that. Now, looking at these fasteners here, which we are going to be engaging on before we start the actual drawing, we need to look at the washer, we need to look at the nut, we need to look at the bolts, the bolt head, the threads, and the threads. All right. Now, let us start with the washer. If you notice here, the washer here has a hole which needs to fit or go through the bolt. That's the washer. And we have the nut again. Now, the nut has threads which we call female internal threads. These threads must fit in to this male external thread, which is your bolt. How so? We first put in the washer, then we bring in the nut so that it fits into our male external thread, which is our bolt. Okay, so that's how it works. You'll notice also that here is my bolt, a very long one. It has threads, male external threads. So how do they represent this to us as a drawing? Now, they give us as an M. M stands for threads. Right, so I'm going to move this away so that I show you what or how we're going to represent this in terms of drawing. So, calculations rather. So, let's say they give you M20. Let's move this away so that we focus. Let's say they give us M20. Now, there is what we call across flats, AF. The formula for that is we must multiply M by 1.5. There is what we call capital letter T, which is for the nut. There again, M, we multiply M by 0.8. There is what we call small letter t, which is your bolt, right? That is an M multiplied by 0.7. Now, it's important that we understand these formulas, because once we lose track of these formulas, then it becomes difficult for us to draw, especially if we are in metric. So let's put the nut over there. If I say M20, they are talking about this part here, which is M20, the outer diameter of the threads. That is your M20, if they gave you the nut. What if they gave you the bolt? So for the bolt, the M20 will be this external part of the threads. So that will be your M20. Now remember, if this nut fits into this bolt, it means both are the same size. So once they give you M20 there, then you must know that is also M20. Likewise, if they give you M20 for the bolt, it means the M20 for the nut will fit in exactly there. All right, so let us start by thinking about across flats. Let's start with across flat. This part here and that part is flat. that surface is flat, 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 flat. So what they are saying is when they say across flat, it means from the flat surface to the opposite flat surface. That is the distance across flat, which you need to work it out. Then, how then to work that out? So let's move this away so that we are focusing. So it means M is a 20. So we're going to say 20 times 1.5. Now 20 multiplied by 1.5 should give us 30 millimeters. 30 millimeters. So it means then, people, from this flat surface to the opposite flat surface, the distance is 30 millimeters. How did we get that? We use the M, which is your external, or rather, which is your outside diameter of your threads, be it a nut or a bolt, but it should still give you the same thing. So the distance from there to there is 30 millimeters across flat. Now, let us look at the nut, capital letter T, which multiply by 0.8. So M, which is 20, remember we are given 20 as an example, we multiply this by 0.8, which is equal to, now if you look at it, 0.8, you should be getting 16 millimeters. So this here, it's for the thickness of your nut. Now, the thickness which I'm talking about is that if we place this like that, let's put it like that. So the distance from there to there is the thickness that I'm talking about. So this distance is equal to 16 millimeters. The distance from there to there is 16 millimeters. That is for the nut thickness. Now, let us calculate the bolt thickness, which is M again. Using the M20 which we are given, then we say 20 multiplied by 0.7, which is equal to 14 millimeters. So it means if I was calculating for the bolts, I need to get that distance to be 14 millimeters. Remember, it's the same thing, it's the thickness. And that's how we get our formulas right. Then, threads here. You see, let's put it like that. The threads, they go deep. So, how then do we know the distance? How deep do they go? We then say diameter. The diameter and this M, it's one and the same thing. It's just that the M indicates that these are threads. So we then say 20 or diameter, let's put it formula, diameter times 0.1. All right. Then we say 20 times 0.1. It should give you 2 millimeters. 2 millimeters. It then says, if you had to draw, that's your bolt, you want to draw the threads. So it simply means that from that distance to that distance is 1 this side and it's 1 on the other side. So all together you're getting 2. So that's 1 millimeters and 1 millimeters. Then all together you're getting how much? You're getting 2. Why? So we added these 2. That's how we get to know that distance from there to there. We multiply the diameter, which is same thing as M, 20, multiplied by 0.1. Then we get our 2 millimeters. Then we get to know that distance. So from now, I'm going to show you how to draw.